Welcome back to the Coding Immersion Journey. After mastering strings, it's time to talk about storing multiple values at once. Today, we're comparing fixed-sized arrays against dynamic lists across C, C++, Java, and Python. Let's jump straight into it. The fixed array trap in C. Arrays are fixed in size. When you declare int numbers 5, memory is allocated instantly. But what if you want to add a sixth element? You can't. You'd have to manually allocate a bigger memory block using malloc or re-alloc. It gives you total speed and control, but leaves zero flexibility. Dynamic vectors in C++. C++ keeps C's raw arrays, but introduces std.vector. By including /vector, you can create a collection that automatically resizes itself using .pushback. You get low-level C performance with high-level dynamic convenience. Java's ArrayList. In Java, standard arrays like int/array are fixed just like in C. But Java gives us ArrayList from java.util. Instead of fixed sizes, .add dynamically resizes the array under the hood. The trade-off? Primitive types get wrapped into objects, which adds a tiny bit of memory overhead. Python's dynamic list. Python doesn't even have traditional fixed-sized arrays built in. Everything is a dynamic list. You can append integers, strings, and floats into the exact same list using .append. It's flexible, handles memory behind the scenes, and requires zero setup. The analogy bridge. Think of a fixed array in C like a wooden storage box. Once it's built, you can't make it bigger without building a whole new box. Dynamic lists in C++, Java, and Python are like flexible backpacks. They stretch automatically as you throw more gear inside. From manual memory allocation in C to Python's effortless dynamic lists, every language handles collections differently based on its core design. If you're enjoying this series, hit subscribe. In Part 11, we're diving into memory management with pointers and references. See you in the next one.